All right, let's get started. Okay, so today, like I just said, it's our 4th workshop. You can watch our previous workshops on our YouTube channel. It's actually right here. Yeah, this is our YouTube channel. You can watch all the recordings of our previous presentations here. Personally, I recommend the data analysis ones because I know that a lot of students are working on data analysis right now, finishing up their projects. We didn't have a super big turnout for these workshops, but we do go over a lot of basic things that will really make you stand out at the fair. So highly recommend data analysis. And then the rest of the things that I said. All right, moving on. Okay, so we're just gonna go around. The SLB is going to introduce themselves. Just for SLB members, just say your name, your grade, and also your project category. So hi everyone, I'm Jessie. I'm in the 12th grade, so I'm a senior, and my project category is biochemistry.
Hi everyone, I'm Ellen. I'm a sophomore and my project category is computer science.
Hi guys, I'm Sanjana. I'm a senior and my project category is environmental science.
Hi, my name is Cara Fan and my project is microbiology.
Hi, I'm Andrew. I'm a junior and my project is medical health sciences.
Hi, I'm Kelly and my project is in microbiology.
Hi, I'm Kavya. I'm a sophomore and my project was in environmental science.
Hi, I'm Eleanor. I'm also a sophomore and my project is in microbiology.
Hi, I'm Emily. I'm a senior and my project is in environmental engineering.
All right, awesome, thank you. So these are the students that will be helping run the breakout rooms. And as you can see, we each have like a kind of different expertise, varied expertise. So hopefully we'll be able to give you some insights for your particular category. Okay. So today we're going to be going over the components of a notebook, writing your abstract. These slides, we're going to be going more into depth with the screening slides because those deadlines are coming up. And then judging slides, we're going to briefly kind of mention them, but again, don't worry about these after you've completed the screening slides. We're trying to reduce confusion here. And then, so these are the breakout rooms that I have that I was kind of making sure that we have enough students to go to, so yeah. All right, Ellen?
So I'll be first talking about putting together your project notebook. So just a little bit of overview of what you guys should have right now or be somewhat set for. You should more or less have your introduction, literary review, hypothesis and purpose, methods, results, and data analysis written up or in the process of being written up for your notebook. And this is a required component of this year's fair. So after you have that, the next things you should be working on are the conclusion, recommendations, acknowledgements, citations, and appendix. So what goes into the acknowledgements? You would want to thank any teachers or others that have assisted you in the project in the acknowledgements in the somewhere near the beginning, as well as all your raw data in the appendix. The last thing you should do is write your abstract, which is a 1-paragraph summary of your entire project, and then adding a table of contents and title page in the front. So the abstract could be one of the more difficult parts, so we're going a little bit more into depth into what your abstract should look like. So now we'll just go briefly into these components. So the abstract is basically a summary of what, why, and how your project really works. And essentially it's a 1-paragraph question, a 1-paragraph summary of the question you asked, what you did, your results, and why they're important. So it's like kind of an executive summary of your work. And it's usually always written last and is about 250 words or less. So this kind of varies with science and engineering projects. So for science projects, you would cover the problem, hypothesis, procedure, results, and conclusion. And then for the engineering projects, you would cover the initial problem, the design process, testing, redesign, and evaluate the final design success. So note that the abstract is the first thing that categorical and professional society judges read. So it's really, really important. And it's like one of the first impressions that you'll make on them. We'll also, like Jessie said, be having a breakout room with sample statements and a further breakdown of this abstract if you've never written one before. So now a little bit into the review of literature or otherwise background research. So this is basically the body of research that you would do prior to starting your project. So for example, if you wanted to research into the history of the problem up until why it's important, to details on experimental design and other interpretations. So this is basically like the why and what exact problem that you're trying to pinpoint and solve with your project. So some questions that you want to ask yourself while writing this part is, what is the problem in its history? Why is it important? What have others done to test and address it? This one's really important to make sure you're doing something that is building off of other scientists' work. Also, what is your method? Why is your method the best way to investigate it? So you really want to review this before you present your project, because a judge may ask you questions about the background research. And although it's okay not to know exactly like every single detail, you should be able to know the problem very well and be able to say why it is important and how it is related to your project. So to further expand on why literature review is really important, we'd just like to remind you that literature review is an essential component of any scientist's work. So this is because it's really important that you understand the current situation in the field and that you're not repeating anyone else's work, since that would be a waste of time, but rather building on it or like improving it in some significant way. It's also how you justify why your work is important, and by summarizing like what others have done and why yours is different.
So the next part of your notebook is your hypothesis and statement of the problem. You should have come up with this when you were starting your research, but basically it's stating like what you think will happen, what you predict, and what the initial problem was. In the breakout rooms, you can also ask us for individual help if you're not really sure how to phrase this. So next we have materials and methods. You essentially make a list of the materials you use, followed by a detailed description of your procedure or how you did your experiment. Things to note are you should always use the metric system for all of your units and be very explicit with your procedure. So you need to be detailed enough so somebody could replicate your results when they perform the same exact experiment. The next section is the results. So we did a workshop in December where we went more into depth in the best ways to analyze and display your work, which you can find the recording for on our YouTube channel. But to summarize, you basically want to show and present all your data in graph form with proper labels, legends, and colors. And you should also label your tables really nicely, but save them for your appendix. So, especially if they're really long, which we will explain a lot later. When you describe your results, you want to make sure to keep out all the interpretation and opinions of the data. You just want the data itself. After your results, it's a good thing to further process your data with some analysis, such as calculating averages, errors, percent differences, trend lines, p-values, or linear regressions. And by calculating these values, you can better describe or prove a point about your data by comparing averages or demonstrating that a result is statistically significant. So if you would like to learn more about types of data analysis, we also have a video on our YouTube channel for both the basic and advanced data analysis workshops that we held in December. And after summarizing your data and the results, you get the chance to write about your interpretations and opinions on the discussion and the conclusion. So when you analyze your findings, you're taking the data information and your interpretations of the data and explaining like why you think things happen. You want to ask yourself questions such as does the data support your hypothesis and why or why not? Your literature review especially comes into handy here because you can reference what others found and build upon their own interpretations. In addition, the discussion section is a great place to expand on why you think your results didn't go the way you thought they would, or address any unexpected outliers.
Another important part of the science fair project is the recommendations. So this is something that judges will always ask you about, and it's one common way is like, what is like one flaw with your project that you would improve on, or like what is an possible experimental error for your project? And you definitely need to have this in mind and be ready to answer any questions. So for example, you could say like, depending on your project, I could use more samples next time because I have a small sample size, or I needed to like due to the limitations of my equipment, I wasn't able to measure as accurately as I would have liked. And you should keep in mind how you would improve your project, how you would adjust your procedure to make your project better. What would you not do? So what was a mistake or something you did that you maybe shouldn't have done and you won't do it next time? And you should also talk about if you plan to continue your project, if you plan to implement it, and if you plan to perhaps publish or even patent your work. Next slide, please. And another important part is citations, which you always must have as a scientist. And it's just a list of references, such as commonly like online research articles that you looked at and used in your research. So you always must credit them, especially if you use the direct quote, but you usually just paraphrase anyway. But just make sure you have the citations so the judges can check as well. And if you are a high school student, you need to have 10 references. And if you're a middle school student or below, 5 references is fine. And you can use either MLA or APA style, but whatever you choose, make sure to stay with it and don't mix them around. Some great online citation sites are Citation Machine or Zoterobib. In the appendix, which is at, like near the very end, you should include raw data for your experiments before like putting into a nice graph and everything, because the judges do like to see that, and it is just like standard to have. So this includes tables and charts, maybe notes and observations from when you're doing your experiment, your participant form, any photos you may have taken of your experiment, and any other evidence. If you're doing like a behavioral project, like for example, you surveyed people on whether they like pineapple on pizza or not, you should only include a blank survey form and a blank consent form in your documentation. Never use a form that has someone's actual responses, because that is like a violation of privacy and like privacy consent. So you should never mention anybody's name or personal information or individual responses in your posts, in your virtual slides or your screening or just anywhere.
So now that we've covered all of the components of the notebook, we're going to do a brief tutorial on how to write a strong abstract. The abstract is written last, but goes in the front and is usually the first thing that judges read. It can attract society or special award judges to your project and give division judges a chance to pique interest. So it should be really succinct but powerful. At our fair, it's limited to 400 words, but we recommend being able to write it shorter because higher fairs are even stricter in word count. You want to summarize your project in 4 small paragraphs. That includes your hypothesis and statement of purpose, your procedure, results, and conclusion or interpretation. Make sure to briefly touch on how you started the project and why it's important by summarizing the problem, and then cover the experimental design and only your main results in a few sentences, as well as an extra sentence on your main data analysis interpretations. And finally, end with a conclusion that retouches on why your project is important and how your results address or elucidate a problem. And also note that this is written in the past tense. Here's a template of an abstract that you can use to guide your writing for science projects. So like we said, paragraph 1 summarizes some background and introduces your problem as well as your hypothesis. Paragraph 2 is a summary of your procedure. Here you shouldn't list the specifics of your materials, only cover the materials you use to alter the conditions of your experiment. In addition, only include procedures that you performed yourself. And if it's a continuation project, don't cover procedures from previous years. Next, in paragraph 3, provide only key results that lead directly to your conclusions with only main data calculations. Then in paragraph 4, conclude in 1 to 2 sentences on what you found and what it says about your original problem. You may also briefly mention your further recommendations and translational implications for your work. So here's a template of an abstract that you can use to guide your writing for engineering projects. Paragraph 1 summarizes what the problem your device is trying to solve. Paragraph 2 is a description of your first design and also should cover your initial reasoning and why you thought it would work. Next, in paragraph 3, talk about how you tested the effectiveness of your designs and briefly go over the changes you made to further prototypes. Then in paragraph 4, Conclude in 1 to 2 sentences on your final prototype and how well it addresses your initial problem. You may also briefly mention your further recommendations for additional prototypes. Here are more tips for writing a strong abstract. Revision is key to help you leave out unnecessary details and discussions. Write in short but complete sentences. Avoid extra jargon and any slang. And as always, check for correct spelling, grammar, and punctuation. Ask for writing help from an English teacher or librarian. Writing an abstract is an exercise in using language effectively to convey scientific ideas and procedures. It never hurts to have an extra pair of eyes glance it over. Convey prefacing ideas instead of details, and prove that your project was scientifically rooted and produced intentional results.
Now that we've covered all these parts of the different of the notebook, we're gonna go over the next thing that you need to turn in for the fair, which is the digital project screening. So the digital project screening is a lot like the safety pre-screening that you guys had to turn in before, but that it has more details. So essentially, we want to make sure that the project you're going to submit is within all of the GST SCF rules, and it's appropriate for the fair. That way, you're eligible for the fair. So it's a last check for the forms that you need and the procedures that you performed. And then please note that each grade level has a different deadline for screening. So here on the slide, we have the different deadlines. 6th, 7th is Wednesday, January 20th. 8th grade is Friday, January 29th. And 9th through 12th grades are Monday, February 8th. And then if, for example, if your project does not meet the criteria, then you will have a resubmission deadline, which is Thursday, February 24th. So to submit, you should look on the GST SCF website for a Microsoft PowerPoint template that you can copy and paste the appropriate information into. And make sure to note that there's separate junior and senior templates, and that this project screening is essentially a condensed version of the notebook. Also note that project screening is not the same as the judging. So the judging is when you present your findings to live judges, whereas the project screening is just to make sure that you followed all the safety guidelines and that your project will become competitive at the fair. So to turn in your project for screening, please go to teachers, then screening information on our website to download the project templates, and then make sure your slides are clean and easy to read, and they're a summary of your work. So use a maximum of 2 fonts and 2 colors to make it look clean, and then as well, make sure to check for spelling, grammar, and punctuation. So you're going to submit this project screening similarly to how you submitted your pre-screening form through the GST SCF website, and make sure the status is submit so the screeners can see your work. So the same area where you submitted the previous forms, you'll see another place to submit it there as
well. So now I'm going to talk about a brief overview of what the template should look like, because they have significant differences between the junior and senior division. So you'll start with the title slide, and then your abstract, background, statement of purpose, and hypothesis. After, you'll get 2 slides to describe your procedure and include photos of the experiment if it's applicable. Next, you'll get 3 slides to discuss your results, including space for graphs, statistical tests, pictures, and a summary of your findings. The next slide is the conclusion and the discussion or interpretation of your results. And lastly, you'll end with your references. After you complete and submit your slides, you may be approved to apply to the fair, also through the portal. Applying to the fair asks for fair payment, and this year is $25. You also may not be approved because you simply demonstrated a concept that didn't actually test the hypothesis, or you had too many inadequacies, or violated the Greater San Diego Science and Engineering Fair rules. In addition, you may need to resubmit with some modifications based on comments from your reviewer. To do this, you go to the portal and redo your PowerPoint based on their comments and resubmit the project as soon as possible. The application, the application to the fair after approval must be submitted and received by February 24th, 2020 this year. The fair application is just a formal registration, including the payment of $25.
After you're approved for applying to the fair and submit your payment, you should start on your judging slides, which are in the Lou poster of this year. This year, the Greater San Diego Science Fair will be virtual through a special platform, and the judges will conduct interview presentations virtually. You will present a slide deck of your work instead of a trifold backboard, which will be similar to the digital product slides, but an emphasis on visuals. The template for these slides will be made available to you after you submit your Greater San Diego Science Fair application and the payment, which you may do after you're approved for the digital project screening. And this is just to reduce confusion with the digital product slides, which are slightly different. And we aren't gonna go over it too much here, but the template is very easy and straightforward to fill out. If you have any concerns once it's made available to you, you can email us at gsdsefslb@gmail.com, or you can DM us on social media.
Okay, guys, so that's the end of our brief presentation. I know that was a little bit of there's quite a bit of information in a little bit of time, so we're going to have like separate rooms in case you have further concerns about any of these things. And also, these workshops are really a really good chance for you to talk to students who have done really well at the fair about your projects. And ways that you can improve them and ways that you can like talk about them in a way that is compelling to judges. I guess before we go into breakout rooms, I'm gonna show you where to find some of the stuff on the website because I thought that might be really useful. So when you go to gsdsef.org, this is our website, right? And so I'm assuming everybody's made an account and has passed a digital project reading this year. So you would like log in and it'll show up as like projects and you just turn in your slides through that. But you find the slides through here, going to teachers and then screening information. And so this is this is an example, but this is the digital project template. So for those in 6th through 8th grade, you would use this template, and then the senior division project. So everybody in high school is going to use just this template, right? And so this is actually just like Microsoft Slides. It's really straightforward. Yeah, it's very straightforward and easy to fill out. So that's where you find that. And then you just turn it in.
Jesse, may I ask also, please go to students right now. We've made a change. Go to students, how to participate. Okay, and scroll down, please, to about step 6. And we want to show you that at step 6 here now, okay, notice please that we have now included all of the screening slide deck information there within the student dropdown. Okay, so notice it's there as well in students and in teachers now. So we've made that change, just so everybody knows. Thanks. Just as of yesterday. So.
Oh, awesome. Okay. All right. Oh, also, that just reminded me, I wanted to mention that we do have a sample notebook. So we just went over the components of a notebook. If you really want to look at another sample, you can go here. This is a sample notebook. So this is a notebook that's more or less actually filled out for an actual project. So here's a checklist of all the stuff we just went over. And then this is an actual like project that you can kind of look over and get an idea for, and it just summarizes everything we just said. And it gives you the whole order and like how your graph should kind of look. So this is also super useful if you're still writing your notebook and you need some help, okay? So moving on, we're gonna go into breakout rooms right now. So if